Yes, ma'am.
The graph of the function f is shown above where negative 2 is less than or equal to x, which is less than or equal to 2. Which of the following could be the graph of an antiderivative of f?
So my antiderivative is increasing when the original function is positive. It's decreasing when the original is negative. Good? Okay? So let's see. Everything between these two is positive. So I'll put a bunch of plus sign. From here to here is negative. Oh, there you go. So everything above the x-axis will be positive. Everything below the x-axis will be negative. So I'm going to make my little visual over here. So we know it must be increasing from these 2 points, and it must be decreasing at the endpoints. So let's first look at where we have an increasing part in the central location. Is that always increasing right here? Nope. Is this always increasing? Nope. Is that always increasing? But is this always increasing over here? Yes, it is. So from here to here, we are increasing. So I'm going to color coordinate this. It is going up. And then the tiny endpoints, it is going down. So therefore, it's got to be D. So the PVA card is very, very, very useful. So let's go on to the next page. We're on 82. Okay, for number 82. Colin, let's read.
Particle travels along a straight line with a velocity v of t equals 3e power of negative t divided by 2 sine of 2t meters per second. What is the total distance in meters traveled by the particle during the time interval 0 is less than or equal to t is less than or equal to 2 seconds?
Okay, let's all underline total distance. On our old packet, we also wrote total distance is always the absolute value of the velocity. It is always the absolute value of the velocity. Oh, that's a v of t. And to find the total distance, we have to integrate, but we don't have to integrate by hand. We have our calculator. What was a mode? Math what? Math number 9. Very good. And literally what we're going to do is integral from 0 to 2 of the absolute value of the function given. I would say the only annoying thing is typing out the function given. So let's all do that together. Math 9, from 0 to 2, of the given function. So we have 3e to the power of, I'm going to do alpha y equals, negative x over 2. Then we have sine of 2x. There's something on the screen. Actually, it's on the board, right? And it should give us one of the answer choices. Did I forget the absolute value? Oh, I would. Let's see if I can do this without. No, it'll make me type it all over. So math 9. Like I told you to put absolute value and I forgot. Okay, do we all know how to find the absolute value symbol? You go to math, second function, and it says absolute, and then I'll type it again. Silly me, negative x over 2 sine of 2x. You should have gotten 2 point something. 2 point how many? Let's see. Should be 2.261. It's taking a while. Yep. So for all the ones that could be potentially a freebie, please don't miss it. Okay, number 83. Kaylee, let's read.
Let f be a function with derivative given by f prime of x equals x to the third minus 8x squared plus 3 over square root of x to the third plus 1. For negative 1 is less than x is less than 9. At what value of x does f attain a relative maximum?
So let's underline the original function has a maximum. So let's look at our PVA card. So when f prime goes from positive to negative, we have a maximum. So if it goes from positive to negative, did I say negative to positive just now? Okay. If it goes from positive to negative, we have a maximum. If it goes from negative to a positive, we have a minimum. So let's write some side note. When f prime goes from positive to negative, and I want to actually look at the graph. If we can let the calculator do all the work, might as well. I will do y1 0, because 0 is a guaranteed number between positive and negative. And then for y2, let's put in that complicated function. Minus 8x squared. And then square root x cubed plus 1. And let me double check. Yep. And I would start with zoom 6, and if you have to modify the window, go for it. So I'm going to go zoom 6. And we're looking for positive to negative. Do we already see the graph at positive to negative? This point right here? Yes? So let's do second calc 5, and I'm going to hover close to it. And how many times should we enter? 3 times for the intersection. And that's going to say 0.638 something. So our best answer is what? See, it is. Let's go to number 84. On the back. Yep. 84, I feel like you don't even need calculus. Gavin, go ahead and read.
The number of bacteria in a container increases at the rate of RT bacteria per hour. If there are 1,000 bacteria at time equals 0, which of the following expression gives the number of bacteria in a container at time t equals 3 hours?
So we know we have to include this initial. So at some point, initial, I need to see 1,000. Where do I not see 1,000? A and C. And if R of t is the rate to find the total bacteria, we're going to need to integrate. And then from between E and D, which one has integral? Done. It is a freebie. Do not miss this question. Okay. So if you were to kind of think about it, just because we're on 84, 85 does not mean it's hard. Okay? And then let's go on to number 85. Addison, go ahead and read.
The function g is continuous in close interval 1 to 4 with g of 1 equals 5 and g of 4 equals 8. What of the following conditions which would guarantee that there is room state in the open interval going forward g prime of c equals 1?
Okay, I want you to circle g prime of c. Doesn't g prime of c represent derivative? Yes? So if there is a derivative, that means it is differentiable, correct? If it was differentiable, it was also continuous. So let's go back to the question. It is continuous, and our next thing is it's got to be differentiable, which means A, B, C, and D. Which one has that? It is differentiable. Done. That's simple. If there is a derivative, it is differentiable, therefore it must be continuous. And that was stated. Good?